Hello and welcome to Math Lessons with Linda. Today's topic is how to write a polynomial function when at least some of the roots are complex. So here's our situation. We would like to write a polynomial that has a degree of 3. So that means the largest exponent is going to be a cubed. You need to be given at least some of the roots. So today I'm going to give you x equals 8 and x equals 2 plus I. So this is our complex root. I only gave you 2 of the roots. We know we need 3 of them. So that tells me that for this imaginary or complex root, I have to use its conjugates because complex numbers always appear in conjugates. So the conjugate of 2 plus I is 2 minus I. I only changed the sign on the imaginary part of that value. So now I've got 3 roots, so my degree is satisfied. And in order to write the function, I need to get factors from all of these roots. So the real number factor is the easiest to do. I'm going to take my root, x equals 8, and I'm just going to set it equal to 0. And to do that, I'm just going to subtract 8 from both sides. So x minus 8 is one of the factors that I'm going to use when I write my polynomial function. So we'll save that. I need to deal with these complex roots. So there's a very straightforward way to figure out what the polynomial will be with both of these factors, right? I know I'm going to have an x squared because I have 2 of these. So like if I were foiling it. But I also need to know the sum, which is going to give me that middle term coefficient. And I also need the product, which is going to give me that constant at the end of my polynomial. So if I do the sum of these two, 2 plus I plus 2 minus I, notice that the imaginaries cancel out because these are conjugates. That's what I should get. So when I get my sum, it's 4. But remember also, if I were actually foiling these out, which would be very time consuming because I would have an x and then the 2 and the I, and it would take a long time. When I multiply a positive times a negative, which is what I've got here, I'm always going to get a negative for the sum. So after I've added them together, whatever my sum will be, I'm going to take the opposite of that. So my middle term is going to be a -4 for the coefficient. Now for the product, I need to multiply together 2 plus I times 2 minus I. Now again, when I do this and I start foiling, 2 times 2 is 4. I get a minus 2i here. And then when I multiply the next one, I get a plus 2i, and then a minus I squared for this last one. So again, these middle terms cancel out. That's what happens with conjugates. So now I just need to deal with my I squared. It's a very common thing with imaginaries. I squared is used a lot. Its equivalent value as a real number is -1. So if I have minus times -1, this turns into 4 plus 1, which is 5. So my product value, which is my constant, is going to be 5. So I'm going to erase a little bit because now that we have these values, I know that the polynomial just for these 2 roots is going to be the x squared. Here's where your sum of -4 goes. It's the coefficient for your x term. And then our product was +5. So this is the representation of these 2 factors having been multiplied together. Remember, we have our other factor from the beginning that was the real number. So you've done the hard work now. All we have to do is multiply together the x minus 8 and the x squared minus 4x minus 5. This is just a lot of distributing. So x to the third minus 4x squared plus 5x. Then we'll move here to minus 8x squared, a plus 32x, and a minus 40. So I have a few terms I can combine. I only have one cubed term, so I used that. I have a minus 4x squared and a minus 8x squared. It's a minus 12x squared, so those have been used. 5x and 32x gives me a 37x, those are used, and my minus 40. So all of these multiplied together, since these are all my factors which represent my roots, is equal to 0. This is my final polynomial function for the roots that I was given, and that is how you write an equation with complex roots.